The essential question of this lesson is, what are the characteristics of the graph of the tangent function? So the vocabulary words start with the word asymptote, a line a graph approaches towards but never intersects. The period: in a periodic function, the horizontal length of one complete pattern. The amplitude: in a periodic function, half the distance between the minimum and the maximum. The x-intercept is the points where the graph crosses the x-axis. Transformations are translations, reflections, shrinks, and stretches. Local maximum, the highest point of any nearby points, and local minimum is the lowest point of any nearby points. Exploring tangent and cotangent functions. So as you can see, we already graphed the tangent function, but we haven't done cotangent function yet. The graphs of the tangent and cotangent functions are related to the graphs of the parent functions y equals tangent x and y equals cotangent x, which are graphed below. So if you look at the table of values, this is pretty much the same table of values that we have created in our first graph for the tangent function. So we started with 0, and that was a point of 0 right here, right? And then we went to, actually we did pi over 6 and pi over 4 and pi over 3. However, in this graph, you only see the pi over 4 and the negative pi over 4, and then the pi over 2, and a couple of values in between. So if you look at the tangent function right here, it's an increasing function. It's only increasing. It's not decreasing anywhere. And if you're looking at the end behavior of the graph, as we go towards positive infinity, the graph goes towards positive infinity, and as we go towards negative infinity, the graph approaches negative infinity between all those asymptotes. So if you're looking at a tangent function, similarly to the sine and cosine function, we are going to kind of graph it with the 4 parts, actually starting from the 0 all the way to 2 pi on sine and cosine, and here we are going to graph between those asymptotes. So our sine and cosine function had the period to be 2 pi, and if you're looking at this graph, the period is only going to be pi, because it goes from negative pi over 2 to 0, which is a half pi, and then it goes from 0 to pi over 2, which is another half pi. Together they make up the whole pi, which is a period of just a pi section. So if you're reading the rest of the text here, because of tangent x is sine x over cosine x, tangent x is undefined for any x values where cosine x is 0, such as plus or minus pi over 2, or if you convert that radian measure into numerical measure, is 1.571. So you can see that at negative pi over 2 and at pi over 2, if you look at the unit circle, we can see that cosine x would be 0. And so that's the reason why the asymptotes appear there. And again, we are going to break the function into 4 parts: the quarter part, the half part, the 3/4 parts between our 2 asymptotes. So now we are going to look at the cotangent function, which is the reciprocal function. So you can use a similar approach to graph cotangent x, y equals cotangent x, because cotangent is the reciprocal of tangent, so it's cosine x divided by sine x. Cotangent x will be undefined for x values where sine x is equal to 0. So you can see how the y-axis as well as pi and 2 pi, and at negative pi we have our asymptotes for cotangent x. The graph has asymptote at these values, and the period again from 0 to pi, which is going to be a pi period. This graph, if you look at it, it's always decreasing. So as we go to the right, it goes towards negative infinity, and as we go to the left, it goes towards positive infinity in between the asymptotes. And again, if you look at the graph, you can see the quarter point, which is here, the half point, the three-quarter point, which we are going to use to graph this cotangent graph. So if you look at the big differences between the graphs, the tangent graph is going to cross at 0, 0, and it kind of, the two asymptotes kind of hug the y-axis. Half of the period is to the right, and half of the period is to the left of the y-axis. However, if you look at cotangent, cotangent graph starts with the y-axis and goes to pi, so the entire period is going to be to the right of the 0, 0 point. Characteristics of y equals tangent x and y equals cotangent x. The functions y equals tangent x and y equals cotangent x have the following characteristics. The domain of y equals tangent x is all real numbers except multiples of pi over 2. At these values, the graph has vertical asymptotes. The domain of y equals cotangent x is all real numbers except multiples of pi. At these values, the graph has vertical asymptotes. The range of each function is all real numbers, so the functions do not have minimum or maximum values, and the graphs do not have an amplitude like the cosine and sine functions did. The period of each graph is only pi, not 2 pi like in sine and cosine functions, and the x-intercepts for y equals tangent x occur when x equals 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and the x-intercepts for y equals cotangent x occur at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. So you can see the two graphs right here. One of them is y equals a times tangent bx, and the other one is a times cotangent bx. Each graph below shows 5 key x values that you need to sketch the graph of y equals a times b of x and y equals a times cotangent b of x. And a is greater than 0 and b is greater than 0. These are the x-intercept of the graph, which is in tangent here and cotangent over here. The x values where the asymptotes occur, and here is one of the asymptotes and here is the other asymptote. And then halfway between the x-intercept and the asymptotes, and then the halfway between the other x-intercept and the second asymptote. So at each halfway point, the value of the function is either a or negative a. As you can see, tangent is increasing and cotangent is a decreasing function. Core concept: period and vertical asymptotes of y equals a times tangent bx and y equals a times cotangent bx. The period and the vertical asymptotes of the graphs of y equals a times tangent bx and y equals a times cotangent bx, where a and b are non-zero real numbers, as follows. The period of the graph of each function is pi over the absolute value of b. The vertical asymptotes for y equals a times tangent bx are multiples of pi over 2 times the absolute value of b. And the vertical asymptotes for y equals a times cotangent bx are multiples of pi over the absolute value of b. And do that. In our first example, we are going to graph a tangent function, and it says graph one period of g of x equals 2 times tangent 3x. Describe the graph of g as the transformation of the graph of f of x equals tangent x. So let's start out by figuring out our transformations. So the transformations are going to be vertical stretch with a scale factor of 2 and the horizontal shrink with a scale factor of 1/3. So now let us go ahead and figure out first the period of our function. So the period of our function is going to be pi over the absolute value of b. So that's going to be pi divided by 3. So this is going to be our period. Now, as you remember, half the period is to the right and half the period is to the left of the x-axis. So if I do half the period, that is pi over 3 times 1/2. So that's going to be pi over 6. So here is our pi over 6. And here is our negative pi over 6. So that's where our asymptotes are going to be. So we have negative pi over 6, where the graph is undefined. And then we are going to have our 0 point. And then we have our pi over 6, where we are also undefined. We also know that at 0, our graph is going to be 0. And the reason why, because there is no horizontal transformation. So we know we are going to have the x-intercept at that point. So let us go ahead and graph our asymptotes at pi over 6. So this is our first asymptote. So I'm going to say asympts is x equals negative pi over 6. And the second asymptote is going to be at x equals pi over 6. So now we need to find the quarter points. So that means we are going to have to find a halfway point between negative pi over 6 and 0. So we need to find half of pi over 6. So the halfway point between negative pi over 6 and 0 is going to be negative pi over 6 times 1/2, which is going to give us negative pi over 12. And then pi over 6 times 1/2, which is going to give us pi over 12. So we are going to have pi over 12 and negative pi over 12. So if I were to graph the parent function, then these values are going to be -1 and 1 because our graph is going to be increasing. However, so let's go ahead and graph that first. So here is our 1 and here is our -1. So let's go ahead and graph these 2 points first. And then let's make our graph, which includes our horizontal shrink. However, it doesn't include our vertical stretch. So this black graph here is going to be our y equals tangent 3x graph. Now, if I wanted to graph now my vertical stretch, so at 0, 0, I will have the same point. However, I need to stretch by a scale factor of 2. So here's our -2 value. So we are going to create our new graph, which has a vertical stretch of a scale factor of 2. So the red graph is going to be our g of x equals 2 times the tangent of 3x. We are not always going to graph the parent graph in this case because it's a little bit more confusing to see. However, if you are getting a bigger and bigger vertical stretch, the graph is kind of going to have a flatter and flatter curve in the middle. However, it's still a curve, it's not a straight line. So in this case, we only graphed one period of the graph. And also we can talk about domain and range. So the range we know is all real numbers. And the domain is going to be, for this one period, it's going to be all real numbers except where x is, so x cannot equal to negative pi over 6, and x cannot equal to pi over 6 because those are our asymptotes. And the last thing I would like to talk about on this graph is the fact that it does have a period of pi over 3, because to the right of the y-axis we have pi over 6, and to the left of the y-axis we also have a distance of pi over 6. And if I do pi over 6 plus pi over 6, I will end up with 2 pi over 6 or pi over 3, which was the period that we calculated originally.